In my Rationalizing the Denominator video, I made a note in the comments that I messed up with the answer to example 2b. Hopefully you've had a chance to look at that and figure out what the problem with that answer was. And the problem with it was that I did not simplify the radicals as much as possible. So here's that question. Here's that final answer that I got, 7 root 32 minus 7 root 24 all over 4. And as you see, this root 32 and this root 24 can be simplified further. So when we're trying to simplify a radical, what we always look for is perfect squares that go into that number. So perfect squares that go into 32. I'm just going to start off by listing a few. Does 4 go into 32? Yep, it does. But is there any bigger perfect square? Does 9 go in? Nope. Does 16 go in? Yes, 16 does go into 32, right? So 16 is going to be our biggest perfect square that goes into 32. I can write 32 as 16 times 2. Similarly, going over to the root 24, what perfect square is going to 24? Does 4 go into 24? Yep. And I don't think there's anything bigger that goes into that. So 4 times 6 is going to be 24. And that's all over 4. Okay, so can I simplify this anymore? Yes, I can. So root 16, underneath this radical, root 16 is just going to be 4, right? So I can basically pull out that 16 as a 4. So it's sort of like, say, 7 times 4 root 2 minus 7. And this 4 comes out, because it's a perfect square, as a 2. 7 times 2 root 6 all over 4. And then I can simplify that a little bit more. So I'm just going to simplify what's in the numerator here. 7 times 4, 28 root 2 minus 14 root 6 all over 4. And is that fully simplified? Well, if I think about it, think of this as a fraction, 28 over 4 and 14 over 4. Is there a way to simplify these fractions anymore? Well, yeah, all three of these terms basically have a common factor of 2. So I can divide them all by 2 in order to reduce the fraction, in which case I get 14 root 2 minus 7 root 6 all over 2. And that is my final answer. Notice how all the radicals are in lowest terms, so there's nothing else. They're simplified, fully simplified. There's nothing else I can pull out of them, no perfect squares. The fractions are in lowest terms, so 14 over 2, 7 over 2 cannot be reduced, and also the denominator is rationalized. So that is a good final answer for that question.